Recording.
Yeah, thanks, Aid. And Chris asked a question, the YouTube channel. I used to have that. I don't think I've got the name of the channel in front of me. I know you'd given that to me, in the past side. So if you have that, if you wouldn't mind just throwing it in the
Put
chat.
it in the chat window. Yeah, we'll do.
All right, cool.
So I'm actually going to share a different screen, but.
Oh, cool. Yeah, I still got video and I still got the slide deck. So that looks awesome. So if you're ready, I'll go ahead and kick us off.
I'm ready.
All right, cool. Thanks, Lex. So good afternoon, everybody that's joined us. And for those that haven't, will be listening to the recording, I'll say the regular good morning, good afternoon, good evening, depending on what time you're watching this. My name is Jason Adams. I'm a escalation engineer at Microsoft. I've worked with our speaker for many, many years, thankfully. I've known him very well, great guy. His name's Lex Thomas. Lex has been at Microsoft a long time, but 30 plus years. His background is networking, worked originally with the Windows OS, safe mode, really strong background with supporting customers, both from a account management standpoint and from a technical role as well across many, many, many large accounts. So we're really lucky to have Lex here today that's going to go over some of the networking ins and outs, troubleshooting using command line, et cetera. For those on today's, meetup, feel free to come off mute, ask questions. If you have anything that you want to know more about, feel free to throw it in the chat. I'll be emceeing. And with that, I'll kick it over to you, Lex.
Hey, thank you, man. I really do appreciate that. Yeah, I've been here 32 years. It's 32 fun-filled years. But I've actually been doing network protocol analysis for a little bit longer than that. If you're in the Charlotte area, I used to work at a store called Software City off of Wendover Road, and we sold Amiga stuff, Commodore 64 stuff. I was actually the official Commodore 64 repair person in Charlotte, and we also did Lantastic and NetWare before I came to Microsoft. So I've been doing networking stuff a long time, and it's a lot of fun, and I still love it today. Usually, the way that my day goes is somebody will have a networking issue. I'll give them some options for capturing network traffic, and then I get to analyze that traffic and hopefully resolve their issue. At least that's the goal. Anyway, I've, like I said, been here 32 years, and I love doing this, and I've done it pretty much every day of those 32 years. Today, I thought what we would talk about is command line packet capture and analysis, using command line tools to capture network traffic. It's a great way to do it. You don't have to install anything on the box that you're trying to take a network capture from. In fact, we have some built-in tools now in the Windows OS that allow you to do that just without having to install anything. Just open a command prompt. And so let's get started. And by the way, I want to make sure that everybody understands that this is an open forum. If you have any questions, just raise your hand in Teams. Jason's going to mediate that, and I want you guys to help drive this class. If you have any questions about something I say, please ask. If you have any questions about how to do something, please ask. That's how I know that you're understanding kind of the things that I'm talking about. And it really does add value to the class. If you're thinking about a question, I guarantee that other people are thinking about a question. I probably didn't explain something well, and let's make sure that you ask those questions and rectify that.
Yeah, I think Derek's got his hand up too, real quick, Lex. Feel free to ask the question, Derek.
Cool, thanks, Lex. So my question is just, this is for command line only, right? Is there going to be another session where you use like packet capturing software or other software?
We're going to actually use some packet capturing software today, as well as command line.
Okay. Awesome.
What we're gonna do today is capture the traffic using command line tools, but the analysis piece is you're going to always have to have something like Wireshark or Netmon that you can use to analyze that traffic. I use Netmon quite a bit. I was on the team that worked on Netmon version 3. And so it's one of my favorite tools. Wireshark's a great tool as well, and we can use both. And then, of course, at the application layer, we're not going to be doing a lot of application layer stuff today, but Fiddler would be the tool that you would use at the application layer. And so we'll go through those tools. Make sense?
Yes, thank you.
Absolutely. So to that point, actually, that's just a great segue. There are lots of different ways to do the same thing here, right? Lots of different ways to capture network traffic. The magic is kind of in knowing which tool works best for the scenario that you're in. Sometimes it's a desktop utility like Network Monitor or Wireshark. Those tools have some great benefits. You can watch traffic as it comes in. You can do troubleshooting live while you're capturing, and that's all great. A lot of times it's an issue to install something on someone's desktop, especially in the corporate world. And in those cases, using things like NetSH, or I'm going to show you how to do it with PowerShell. And I love being able to do it with PowerShell. And so we'll walk through that. And then there's some other commands. nmcap is a great tool. I use nmcap all the time. There are some command line Wireshark tools that we're not going to cover today. But each tool has its strengths and weaknesses. The magic, like I said, is kind of knowing which tool is the best in the scenario that you're in. So each of them, like I said, are great at doing specific things, and it's just all about understanding what those things are and which you should use in a specific scenario. So NetSH. NetSH is awesome because you don't have to install anything. It's built in. Every copy of Windows comes with NetSH and has Windows XP. It doesn't need to install anything on your box, no additional drivers. We can script it. One thing that a lot of people don't know about NetSH is that it'll actually survive a reboot. You can start NetSH, start capturing, and reboot a box. The reason that that's huge is if you've got an issue where we're troubleshooting like a slow boot, right? And we think it's network related. Really, NetSH is the only tool that's going to get you that from that capture from the moment the network stack initializes. Weaknesses: limited filtering with NetSH. You can't go in and say capture everything to and from a specific IP address and a specific port that contains a specific flag. The filtering in NetSH isn't that strong, but you can quickly fire off a network trace from a command prompt using NetSH. Does require Network Monitor or Network Analyzer, Microsoft Message Analyzer, actually, to look at the data, to view the output. And it also requires local admin rights to capture network traffic. That's a consistent with any of these tools. Everything that we do, every network capture utility that Microsoft produces requires local admin rights. And that's just to protect you and your data. So here are some common switches that you can use with NetSH, and then I'll give you a little bit of a demo. So capture equals yes.
Yeah, we lost you there for. Hey, we lost you there for 1 second, Lex. I don't know if you could repeat that.
Okay. You want me to start at the beginning of the slide?
Yeah.
Yes, sir.
Who's going to edit this? Are you editing this, Jason?
No, I don't think we're editing this. No, we're not. We don't have a cutting board. I don't think. No engineers on this. No.
Send it to me. I can edit it.
Yeah. Thanks.
All right. So these are some common NetSH switches and parameters, and I'm just going to go through them. I'm going to also do a demo of them in just a second.
Lost you again.
Okay. Can you guys hear me? Can you hear me?
Yes, Lex,
Yeah,
we
we
can
can.
hear you. Yeah.
You're breaking up. Yep.
I'm breaking up. Okay.
Your picture's
Let's,
showing me, but I can hear you.
okay. All right. Let me know if you lose me again. I'm going to try one more time. Common network switches and parameters for network capturing. This is kind of important to understand. Capture equals yes, captures indus traffic. Trace file equals allows you to specify where the trace is going to be saved. Max size determines how much data you're going to capture, how big the capture is actually going to be. And there's some other switches, packet truncate bytes or truncate packet bytes. I'll show you all of that. Max size can go up to 2 gigs. Technically, you could do 1 meg, but I've never seen anybody do that. I don't really know that there's a good use for that. But you could do it. IPv4.address allows you to specify traffic to and from a specific IP address, but that's pretty much the extent of filtering with NetSH. Like I said, filtering is a little bit limited with NetSH. To get help with NetSH, you can just do a NetSH space trace space show, and then capture filter help. We'll list all the capture filters. Providers is interesting. Scenario or scenarios are both really good. You can do show scenarios and it'll list all available scenarios. You can do show scenario and then specify a scenario and it'll show you all of the specifics for that specific scenario. Scenarios are kind of neat because they allow you to capture both network traffic and API calls for a specific scenario. So I highly recommend taking a look at scenarios. All right, and so here's some examples, and I am going to kind of end the slideshow for a second and fire up a command prompt. And let me drag this up to the right screen. And I'll make this text a little bigger for you. Everybody see that okay?
Yes.
Yes, sir.
Okay. Right, let me fix the size of this. Oops. And I lost my command prompt. Hang on just a second. There we go. Let me just make it full screen again. All right. So if I do netsh space trace space start space capture equals yes, and then trace file equals, and then just give it a path. I'll say C:\temp \capture, and then I'm just going to call it user group.etl and hit enter. I can start a capture. Now, one thing that I didn't do is open this command prompt as local admin. So I'm going to hit enter here to show you what happens when you do that. Requested operation needs elevation. So we'll come back down here and run a command prompt as local admin. And you can't see it, but it's prompting me, so I'm just going to say yes. And we'll drag that one over here. Oops, I messed that up. Hang on. 2 monitors that are not next to each other. Not fun. So I want the admin command prompt. Here we go. And let me make that big real quick. And now if I hit enter, we're capturing traffic. Okay, so notice I didn't specify a size. I did that on purpose. The default size is going to be 512 megs, which is probably as big as you want to get. Once you get larger than a specific size, it gets hard to manipulate the trace data. And what I mean by that is you're going to have to open the trace in a tool larger than half a gig. Can take a little while to load. Also, it's harder to filter through. Not that there aren't scenarios where you might have to do 2 gigs. That's something that happens, and if you have to do that, then by all means do that. But by default, we stop at 512. And again, you can change that using max capture size or max size. All right, so let me do a little net sh space trace space stop here, and that'll stop the capture. And then while we're waiting on that capture to stop, I'm going to restart the slideshow, and I'm going to walk you through the examples that I have here, and then we'll do a trace with the examples. Whoops. There we go. Okay, so in this case, I'm doing netsh space trace space start space capture equals yes, and then I'm doing packet truncate bytes. So let's talk about packet truncate bytes. By default, over Ethernet, the typical MTU is 1500 bytes. When you get to the maximum segment size for TCP, you've got about 1460 bytes left. Nowadays, if you're looking at a network trace, you probably don't care as much about the data segment in each packet, right? Because that's normally going to be encrypted anyway. You're looking for things like, hey, did this packet get from point A to point B? Were there a lot of retransmits? Were there a lot of dupacks? Was I even able to establish a TCP session? Am I seeing SYN retransmits? Am I seeing fast retransmits? And is there large time deltas between requests and responses? Is the other endpoint responding quickly? And so in those scenarios, really, we don't need to capture the entire packet. Usually the first 100 or 200 bytes is fine. If I'm troubleshooting a TLS issue, I'll capture the first 500 bytes. I want to make sure that I capture enough data so that I can see the URL that we're issuing a client hello against. And so I'll maybe make that a little bigger. By default, again, it's 1500. It will capture the entire packet. But remember that there is a switch, packet truncate bytes, and you don't have to capture the entire packet. If you want network monitor, if you want NetSH to survive a reboot, persistent equals yes is your friend. If I specify persistent equals yes, I can reboot the box without calling netsh space trace space stop. And as soon as the TCP stack initializes, we will continue capturing data. Again, to stop that, it's just netsh space trace space stop, and that'll stop the network capture. So netsh is really cool, again, for a couple of reasons. Number one, it is built in. You don't have to install anything. Number two, it's very easy, right? Very simple to start a trace. You just tell it you want to start a capture. You tell it where to put the file. If you want to define some additional parameters, you can absolutely do that. And let's, I'm going to show you what that trace file looks like real quick. So I'm going to end the show, the slideshow. I'm not ending the Teams meeting here. And let me go to my temp directory. Hang on just a second. So I'm going to go to C:\desktop or C:\temp, I think is where we put it. C:\temp /capture and user group. And if I double click on user group, it opens network monitor because that's what I have associated with ETL files. And it's opening the trace, and as soon as it gets open, I'll move this over into the shared space. Here we go. And there's a couple of things I want you to know about looking at NetSH traces. If you're going to look at them in Network Monitor, and Network Monitor will read ETL files by default. When you open the capture file initially, let me make this a little bigger for you. You'll see this message. Windows stub parser, select Network Monitor, Windows profile from the parsers pull down. So by default, we'll load a NetSH capture, an ETL file, but we don't parse it using the default parsers. You have to load the Windows parser set to get the parsers that will parse ETL files. And so I just did that, and in just a second, this will pop up and it'll be regular network traffic.
So Josh, did you have a question about the font size, how it's a little wonky? If you want to come off mute, feel free to.
Is the font size too big or too small?
I don't know. Josh had a question there, so it said regarding font size.
I think the frame summary is good now before the default. I think just the
it was
monitor
small.
resolution. Yeah.
Yeah. I've got a really big monitor.
No worries. Thank you.
Yeah, no worries. And there, I can make the hex dump bigger too. And let's make this bigger because I'm going to go into this. Okay, so this is just a wide open capture. What you're looking at is all traffic. Most of this is UDP from 3478 because we are in a Teams meeting. And that is the audio stream. Actually, is it the audio stream? Yeah, that's the audio stream. No, that's the video stream. That's the audio stream. That's the video stream. And that's the desktop share. So I can come over here under other traffic, and I can open up all of the Indus traffic that we captured. And these are TCP sessions, and they're all split out based on IPv4 conversations. So I don't have to build a filter to look at this. I can look at each session individually just by clicking on the IPv4 pair, and then I can click on the sessions underneath that. These are all UDP. There's a TCP session. And let me find one that has multiple sessions under it. There we go. We've got two sessions, two separate TCP sessions between my box and a Microsoft Cloud endpoint. Right, that's session 2. There's session 1. And so it makes it looking at this traffic really easy because you can break it out based on session, right? Based on conversation. Here's a client hello. And if I take a look at the hex dump, I should be able to pull a URL out of that. Let me scroll this over. Yeah, that was login.microsoftonline.com. Right there's login.microsoftonline.com. And so this is TLS 1.2. We have a 0303 somewhere in this hex dump right here. So that's TLS 1.2. This is an IP packet, IP version 4. And all any sniffer does is take this raw hex data, pass it through a set of parsers, and make that data usable and readable. And the ETL file that NetSH creates has all of this traffic and all of this data in it. So it works like a champ. I'm going to go ahead and close Netmon or minimize it, and we'll go back to the slide deck. Any questions about NetSH?
Actually, I have one. Can we filter, like, go into a certain IP address?
Yeah.
Or coming from a certain IP address?
While we're capturing or while it's being displayed?
On the display.
Oh, absolutely. Yeah. Do you want me to show you?
Yes, please.
Okay. So I can build a filter. By default, Network Monitor has a bunch of different filters built in. So if I go to address and then IPv4 address, right, all I have to do is enter the IPv4 address here. IPv4.address is the filter, and then equals equals means equals, right? So 52.108.216.1 is the first address that I see here. So I'm going to go up here and I'm going to select all traffic. And notice that there's just a ton of traffic in this trace. But as soon as I hit apply, that display filter filters only traffic that meets the criteria that I entered. So all of the traffic that you're now seeing here has either a source or a destination IP address of 52.108.216.1. And there's not very many packets here. There's only 16 packets out of 23,063. And just so you know, you can build a filter on anything in any packet. And let me show you that. Boy, you're getting your question answered incredibly completely. So if I want to build I'll just pick flags. If I want to say, show me everything that has an ACK, I can just right click on anything in any packet and then add selected value to display filter. And it'll add that, right? So this is every packet that has the ACK flag set. Right? And somebody's going to say, oh, but there's an ACK SYN. Well, yeah, but the ACK flag is still set. Right? So that works. I can also come in here and I can take that and I can make it a color rule. Let me make this really interesting. So I'm going to say salmon with black text, because why not? And let's move that all the way up to the top. And select OK. And now all of this will be salmon with black text. Looks kind of orange. So yes, you can build filters. You can filter on anything in any packet. And when I say anything in any packet, I actually mean anything in any packet. I'll show you that. Here, let me do this real quick. And I'll just take this byte pattern. Here, we'll do E8 55FC just as an example. So if I come down here to search frame, and I'm just going to kill all the green text. And I'll just explain it to you. So you can search either via ASCII or via hex. Or you can do like uint8, uint16, etc. I'm going to do hex here. And I'll just do E8 55 FC and all traffic. And let's remove the currently applied filter. Okay, so right now there's no filter applied. I'm telling Network Monitor to find the packet that has that byte pattern. And apparently there's a few. There's 21,940. I should have picked a different byte pattern. So let's do that. Let's pick a different byte pattern just to make this completely random. Let's do OCC04D.
Yeah, and while you're doing that too, Lex, Derek's got a question. Yeah, feel free to ask away, Derek.
Okay, I don't want to break your concentration there, Lex, but
Oh no, don't worry.
I understand your bias towards Network Monitor, but for most people who didn't cut their teeth on Network Monitor, compared with a product like Wireshark, would you recommend one over the other, and why?
Okay, so I don't dislike Wireshark. I want to make sure that everybody understands that. I like Network Monitor a little bit better, and I am biased. But the reason I like it is because of the conversation tree, right? With Wireshark, it's a little bit harder to get to a specific conversation. And what I mean by that is I can quickly look at capture in Network Monitor, and I can look at every single conversation. Remember that when you're doing a network capture, we're capturing, it's not one conversation. It's like tuning into every radio station your radio picks up all at the same time and trying to figure out what's actually going on, right? It's a lot of noise, and not all the noise is related to each other, right? So with Network Monitor, the thing I really like about it is that it's given me a list of IP sessions here, and I can just find the IP address pair that I want, and then look at the sessions under that address pair. And if I'm not sure where an issue is, I can look at each one individually and quickly rule a specific session as in or out. Is this problematic or not problematic? And to me, that's just quicker. Right. With Wireshark, you have to look at all of the traffic, look for what you think might be a problem, and then follow that TCP stream.
So does Network Monitor also provide capture filters as well as display filters?
Absolutely. There's only one syntax with Network Monitor.
Okay.
So anything that you can use as a capture filter. So by the way, I just let me just apply this filter, and we'll find the. So there's two packets that have that string, those hex values in them in this trace, and I found them immediately. I can also do this, by the way. Hang on just a second, and I'll answer your question in just a second before I lose my train of thought here. Right, we saw Microsoft Online. I think it was Microsoft Online. Anyway, I know that online was a word that was in one of those packets. So let's do apply, and these are all the packets that have that keyword in them, right? And it's pretty quick. So refresh my memory again. What was the question that you just asked?
Oh, you kind of already answered it. It was whether or not this also does capture as well as display filters.
Yeah. So I wanted to show you that. So if I come in here and I grab this, I can go to, let me just go to new capture. It'll open a new capture here. And then I can go to capture settings, and I can paste this in and apply it. And if I start capturing, it'll only pick up packets that have the word online in them, because that's my filter. So we only have one syntax. We don't have separate syntaxes for capturing or for displaying network traffic. Pretty cool?
Yes, I just haven't used Network Monitor enough to get the feel of it and to navigate it well enough, like I have Wireshark.
Yeah, absolutely. And there's, like I said, I use Wireshark too. Wireshark sometimes has better parsers. We try to keep the Netmon parsers up to date, but it's a community effort to do that. Netmon is no longer really an officially developed product. There were only 4 people on that team, and most of them have gone. There's only one left. And so it's a great tool, but it's not, the parsers aren't as up to date. So when I need Wireshark, I use Wireshark.
Gotcha. I know how you feel.
Yeah. Okay, so PowerShell. I love capturing in PowerShell, and I like it for a couple of different reasons. Again, it's built in, right? Highly scriptable. I can use the commands to start a network capture and put a bunch of commands in between, Go out, hit specific boxes, do specific things on specific boxes, all in the PowerShell script. So it makes capturing specific traffic really cool and really easy. I can also use loops, right? I can say start capturing and capture 10 different traces for a specific period of time each. And the reason that's important is because if you've got an issue that you're not sure when it's going to happen, and you don't want to just start capturing and let the capture run all day, because then you're going to end up with a file that circular logs in most cases, right? So there's a chance you're going to miss the issue. And if you do capture the issue, you have to be there to stop the trace before it circular logs, right? Before it rolls over. And last but not least, that trace is likely going to be pretty big. And so PowerShell kind of helps work around all of those issues. You can write code that triggers the PowerShell network capture. You can read the event log, and then when you see a specific event, you can stop capturing or you can start capturing. It's pretty neat, the things that you can do with PowerShell. And these traces are just ETL files. So you can read them in Netmon, you can convert them to Wireshark, and I'll talk about converting an ETL file to Wireshark in just a second. The only weakness is you really can't look at the trace while it's capturing. You have to capture and then look at the trace. And that's the same thing with any command line network capture utility. If you don't have PowerShell 5.0 or above, you're going to need to update your PowerShell version. Those are really the only two weaknesses. To start a network capture, oops. I messed that up. Hang on. Yeah. To start a network capture, new net event session, and then the parameters, dash name. You're just defining a handle here, and then dash local file path, and then where you want to store the file. And then you can add a network event capture provider. You just reference the handle you created under net event session. And then you can use truncate length, and then you just start the network capture. So pretty straightforward. Previous, I did it again. I'm trying to stop the presentation. Hang on just a second. Let me end the slideshow again, and I will pull up PowerShell, and I'll walk you through my PowerShell script for doing this. So this is my PowerShell script, and you're more than welcome to use it if this is made available after. Save the video. And of course, if you're in this meeting and you'd like a copy of the script, just let us know and I'll happily send it to anybody that wants it. First thing I'm going to do is clear the screen. Then I'm going to write to the desktop, how many traces would you like to run? I'm going to read that in as a variable, and then I'm going to write how long in seconds for capture. And the reason I'm doing this is because I'm going to time and date stamp each of these traces. And if you've got an issue and you're not sure when the issue is going to occur, really, you only need to know what time the issue occurred. And if you can tell me what time the issue occurred, because these traces are time and date stamped, I can go get the trace that contains the data that I care about to help you troubleshoot this issue. Next thing I'm going to do is I'm going to go check to see if the path variable that I declare here, in this case, I'm just going to C:\temp\capture. I'm going to test to see if that path exists. If it doesn't exist, I'm going to create it. If it does exist, I'll move on. I'm going to check to see if there are any existing capture sessions running. People like to Control-C out of these PowerShell scripts, and so if somebody has done that, I just need to stop any existing trace sessions and remove them from memory. And then I'm creating a loop. And I'll flush DNS. I'll start the network capture. I'll do some minor things here like resolve DNS. I do the resolve DNS and I hit bing.com because if I open a capture file and I see a DNS query to bing.com, I know that the trace hasn't rolled over. It hasn't started circular logging. And so that's why that's in there. And then I'll just wait for the allotted period of time, and then I'll stop the capture. And so I'm going to run this for you real quick. Hang on just a second. And I know I could just hit play, but there's a problem with running scripts on this box. So I'm going to have to do it this way. All right, so if I just run the script, how many traces? I'm going to say 3 traces. And how long? I'm just going to say 30 seconds each for the purposes of this class, but I could go as long as I wanted. So if somebody came to me and said, "Hey, I've got this issue. It happens once an hour. I don't know when it's going to happen, but it's going to happen." Okay, I'll usually do 12 traces at 300 seconds. That'll give me 5-minute traces, right? And 12 times 5 minutes is an hour. We can go more than that. We can go really as many as you want. Really, the only caveat here is how much disk space do you want to take up with capture files. In this case, we're going to do 3 for 30 seconds each. I'll hit enter, and we are capturing. If I go to File Manager here, I'm just going to navigate to C:temp capture. And there's the first trace. And that started at 15:48:18. The next trace started at 15:48:48. And there'll be a third one here in just a second. I can do other things. I can dump a process list to a text file. I can dump a route table. Really, anything I can do at a command prompt or in PowerShell, I can do in this trace. There's the third trace. And notice we've got the name of my machine. We've got today's date, September 2nd, 02, and then hours, minutes, seconds. And that should stop here in just a second.
While that's stopping, Lex, talk about dumping the route table. Why would that be important? Because I've been doing a lot more with routing tables here, from my home lab via site-to-site VPN back to Azure.
Yeah, well, I like doing it because it tells me whether or not, it depends on the environment, to be honest with you. If somebody's just capturing from their home network and they might have a wireless connection, then their default gateway is going to likely be their default gateway. They likely are just going to have a local, subnet and their default gateway. And so that's pretty straightforward. That's pretty easy. I do have some customers that do some crazy networking stuff. I've got one customer that I deal with all the time. In their network, traffic either flows to a local network, and they have routes defined for every single subnet, or it goes to a proxy server. And if it doesn't go out the proxy and it's not to something that's local in their environment, it goes to a default gateway, but their default gateway actually goes to a dead end. It goes to a proxy server that logs the attempt, or a firewall, sorry, that logs the attempt and then throws the packet away. And it's just their architecture. And so sometimes the route table is kind of important, right? If I've got routes to multiple networks or multiple network adapters in my machine, traffic can take different routes. And I like dumping the route table so that I know where traffic flows, which interface it went out of. In the network trace, we'll capture MAC addresses. I can go look at the Ethernet layer. I can say, okay, this packet went through this interface to, whatever the next hop is. And so the route table just helps kind of with that a little bit. So my traces have stopped. If I come in here, there are the 3 traces. And if I double click on any of them, again, it'll automatically open up Network Monitor.
Does it just minimize still?
Yeah, it's actually opening up on a different, I've got multiple monitors here.
Oh.
And so it makes it fun. So here's Netmon. And there's the network trace. Now we only captured for 30 seconds. But we actually went out and talked to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 different endpoints, 24 IPv4 endpoints and 1 IPv6 endpoint. And we have multiple sessions over both UDP and TCP to those endpoints.
Is that
And by the way, go ahead.
Is that conversation tree on by default like that?
Yes.
Okay, cool.
Yeah, it's on by default. And I can look at different layers, right? Like if I just want to look at the TLS layer, or if I want to see the entire TCP transaction, I can do that.
No, that's real handy, no doubt.
Yeah. Yeah. So this just, to me, this makes it great. And the other thing, and I'll show you this too. Let's go to new capture. Now remember that I captured this with PowerShell. I captured that trace with PowerShell. But if I actually capture a network monitor, and this is where it becomes really kind of invaluable, is I can hit start here, and I want you to watch the network conversation tree. Because I'm on this box, it can figure out which application is actually sending the network traffic. So if somebody says, hey, I'm having an issue with Teams or Outlook, or here, let me fire up a web browser. Okay, I just fired up Edge. And now we've got Edge. And I can see every single endpoint that Edge reached out to. Right? If I fire up Outlook, I can go see every single box Outlook went out and talked to. And so that makes it really cool. I just stopped capturing, but these are the Teams servers I'm talking to right now. Even PowerPoint is going out and talking to an endpoint.
Oh, that's
Here's
slick.
OneDrive. Yeah. And now because I've got the process names, I can build filters based on the process names. Right? So now I can right click on teams.exe and add process name to the display filter. And now if I go up here, I can look at all of the traffic Teams generated. And I can save it out. I can go File, Save As, and save only the displayed frames.
Can it discern between different services that are all using SVC host? That would be really handy.
Yeah, sometimes we can. A lot of times it'll show up under unknown, which is right here. Remember that SVC host doesn't list individual components as processes, right?
Right.
It just shows up as SVC host. So in that case, I can add a column here. Here, let me show you real quick. So I can add process ID. And then I can take the process ID and look at the process list. And if I've got Process Explorer, I can go to that process. And in Process Explorer, if you hover over a service host instance, it'll tell you all of the components that are plugged into that instance of service host. So you can do it that way.
Nice.
Yeah. In fact, that's the way that I do it 90% of the time. But that's another huge benefit of Network Monitor. This isn't, this isn't designed to be a Network Monitor class, but I'm happy to do a second one and make it then do a Network Monitor class for you guys. And I certainly don't mind talking about it now. But this isn't nearly as in-depth as we could get on Network Monitor. All right, so let me minimize Netmon. And now I've got these traces that are time and date stamped. And if somebody comes to me and says, oh, 248, I had an issue. Well, I know which traces to go look at because I've got everything time and date stamped. Now I can do other things that are pretty neat. Right? I can come in here and I can add code. I can do test dash net connection. And then dash computer name. And where haven't I been today? Oops. I haven't been to eBay. So I'm going to say ebay.com and dash port. And we'll do 443. And remember, anything I can do in PowerShell, I can add to the script. So let's hit enter. How many traces would I like to run? Let's do 2 traces. And we'll do them for 60 seconds. And now it's going to go out and do the test net connection.
Lex, Josh had a question.
Sure.
Josh, go ahead out of mute and go ahead and speak, please.
Okay, thank you. I just was curious if there's any special considerations / advice when capturing with Netmon or PowerShell. If we've got Hyper-V enabled on our system, either we're running VMs or Sandbox, etc. Just thinking about virtual switches sometimes get complicated. Focusing on what we need to capture from. And I saw there's a couple advice in that PowerShell link that someone shared there with the Dr. Scripto, but just wanted to see what your perspective was.
It depends on the issue that you're trying to solve, right? If I've got a VM and that VM is having issues communicating with a specific endpoint, then I'll want to start by capturing at the VM. There are times when you'll capture at the VM and you'll look at something in the trace and maybe you can't get to an endpoint, right? Or it's slow getting to an endpoint. And so then the next step would be, well, let's figure out why it's slow. And so at that point, you'd have to maybe trace it multiple points. And so generally on a VM host, and that's the box that's hosting multiple VMs, I would want to trace on the physical NIC on that VM host, as well as on the VM itself. And then I can build filters that I can use to separate that traffic out in both traces so that I can look and see. What that's going to do is that's going to allow me to verify that the issue is within the architecture of the VM host or if it's external, right? And so that I always start with the box that's having the issue. I had this conversation today with a customer, and they were like, "Oh, well, we weren't able to reproduce the issue, but we took these traces and we noticed that round trip time was X, and we think that might be the issue." Well, what was round trip time? 34 milliseconds. That's not a network issue. 34 milliseconds over the internet's actually not bad. So I always start at the closest, as close as I can get to the box that's having the issue.
Okay, thank you.
Yeah. And then I'll just kind of work my way out from there. All right, so temp capture. And what time is it? It's 4:02. So 59:55. Okay, so just to demonstrate what we talked about, and I'll make this traffic a little bigger because I know it's hard to read. And I'll fix the color rule issue. There we go. Okay, so first thing I want to do is we've got all this traffic, and I'm going to show you how easy this is, right? So first thing I'm going to do is I'm going to go search frame. I'm going to look for eBay. Okay, there's our DNS query for eBay. Then I'm going to come into the DNS packet. And I'm going to grab the first A record. Now, I don't know if this is the one that the address that we actually use, but we're about to find out. So let me clear this. I'm going to open this. Okay, so the first IP address is 216.113.179.53. So do I have a .53 in here? I don't see one. How about a 253? There's a 243. Yeah, I don't see one. 216. Do I have anything going to 216? Okay, so the next thing I'm going to do is I'm going to look at when we got the response. I'm going to remove the filter. And then I'm going to look at the next TCP session. And indeed, we do have a 216. I just was too blind to find it in the stack here. So we did end up going to 216.113.179.53. I'm going to right click on that. And I'm just going to do find conversation, TCP. And it'll find the conversation for me. And we were able to successfully establish a TCP session with eBay. And we successfully tore that session down. And so that was fairly easy, right? We wrote a line in the PowerShell script that told PowerShell to go out and establish a TCP session with a specific endpoint. It did that. It tested that, made sure that it worked, and it tore it down. And we can easily find that in the network trace. And that's just an example, right? That's why I love doing this with PowerShell. It's because I can start the capture. I can execute any command that I want or any group of commands that I want. There's no limit. And then it's pretty straightforward to just stop that capture, stop the trace, and I should have the data that I'm looking for. If somebody says, "Hey, I'm having trouble getting to eBay," well, let's do a test network connection. Hey, I can get there, but you can't get there. Okay, so let's trace that and see why. And then, either it's going to be a proxy server or it's going to be a firewall. If I can get to eBay and you can't, we know that eBay is up. right? So it's not because eBay is down. So pretty neat. Any questions about using PowerShell? Okay. Any questions in general?
I think we're all just letting our heads swell. All right.
Yeah, we're still catching up.
Yeah.
I got a quick question.
Sure.
And maybe I just wasn't paying attention at the time and missed it, but I'm assuming that there's arguments, parameters within that PowerShell command where you could stipulate packet size.
Absolutely. In fact, you can build all sorts of filters. That's a great question. So let me show you that real quick. So add net event packet capture provider is the one that you want, and you can set all of these parameters. Here, let me find it. It's up here, right here. So all of these, right? I can do ether type. Oops. Little quick reminder there. Don't click on anything. I can do ether type. I can do IP addresses. I can do IP protocols. I can do link layer addresses. I can set truncation length. These are all valid parameters that I can add to add net event capture. Right. So if I just do a dash here, I could do ether type space 0x 0800, and that would be Ethernet dash, and then I can set IP protocols, right? And so 0x6 in hex would be TCP, and then dash IP addresses, and then I can use commas between the IP addresses. So 10.10.1.10, comma 10.20.1.10, comma, and then whatever I wanted to do. Right, so let's run this real quick, and I'll show you that those fields get filled out, and we're going to capture that traffic. And then I'll maybe try to ping 10.10.1.10, which I shouldn't be able to do. So we're going to run one trace, and we'll run it for 60 seconds or 30 seconds. 30 seconds should be enough. And what IP address did I say? 10.10.1.10?
I believe so.
Is that what I said? Otherwise, it's not going to work. Yeah, 1.10. Okay. So if I come over here, ping 10.10.1.10. And that's going to fail, but we should still see some ICMP traffic, I think. If my evil plan comes together. Okay. So now if you take a look, right? We've got ether type filled out. There's the IP address. There's the IP protocol. Well, we're not going to capture anything because I said 6, which is TCP, instead of ICMP. So it wouldn't. There's not going to be any data in the trace. But that's okay. I can prove that to you. I should have done a test net connection. Yeah, there's no traffic in the trace. But here are the rules that I specified, and you will see those. So to answer your question, yes.
Yeah, it seems to be a little bit more granular than NSH2.
Yeah, a lot. All right, so here's where we are in the slideshow. Luckily, it's a short slideshow. All right, so NMCap. And then once we get done with NMCap, I'm going to go back and show you some other PowerShell traces or PowerShell scripts that I also use. But NMCap is pretty neat. So if you install Network Monitor, we will install NMCap, which is the command line version of Network Monitor. And I really like NMCap. And there are some situations where I will use NMCap instead of PowerShell. And I'll explain those as we go along. But NMCap is the command line version of Network Monitor. So all of the filters that you can use in Netmon, you can use in NMCap. Highly scriptable. I can apply any filter I want. I can add other parameters, and I'll show you those. It does require that you've installed Netmon on the box, otherwise you don't have NMCap. And again, like everything, it requires that you have local admin. So I just mentioned that the filters are identical, and they are. We use IntelliSense in Netmon, so any filter you can build in Netmon, you can copy and paste into NMCap. And we have a switch for that. It's /frame and then the filter, and I'll show you that. You can use NMCap for long-term capturing, and you can disable conversations, and we won't build the conversation tree in memory. That doesn't mean the conversation tree won't get built. When I open the capture, the conversation tree will be built on the fly by Network Monitor. So there's really no reason not to disable conversations. It just makes NMCap a little bit faster.
So I have to ask then, why is disable conversations an option?
Yeah, that's a good question. It's because NMCap is built on the same engine that Network Monitor is built on, and by default, Network Monitor has conversations enabled. Okay. Right, so it's the default for the Network Monitor engine, which NMCap calls. And so it's really more about turning it off. There's not really a good reason to have it on. And when I'm using that engine from the command line, there's a great reason to have it on when I'm using that engine in the GUI-based tool, right?
Right.
So that's why. You can write to a single capture file, or you can build chains of capture files. And so if I end the file name with .chn, I can specify a size, and it'll just, instead of circular log, when I hit that size, it'll create an additional capture file. So in this example, if I do test.chn:20M, every 20 megs, we're going to write a brand new capture file, and we'll start with whatever the file name is. So in this case, test. So it'll be test.chn, and then it'll be test1.chn, and then test2.chn, or sorry, test1.cap, test2.cap, etc. And we can reassemble. So I can reassemble payloads using NMCap, and we'll talk about why that's important in just a second as well. Okay, so NMCap /network* means capture on all network interfaces. /capture TCP means capture TCP traffic. /file and then tcp.cap means put it in a file called tcp.cap. And it's very easy. So packet reassembly. we have to break data up based on MTU size, right? So with TCP, we have an MSS, a maximum segment size of 1460 bytes, which means that we can't put more than 1460 bytes in each TCP packet payload. And this is standard Ethernet, right? This is assuming standard Ethernet. And so there are times where we send huge chunks of data, but that data gets broken up. In Network Monitor, you can reassemble that data. And you can tell NMCap to reassemble that data as well. So it'll do the data reassembly and then write that out to another file. So NMCap / network asterisk capture, and then in this case, my filter is not ARP and not ICMP and not NetBIOS transport name service and no browser traffic. And then I'm going to name the file nonoise.cap, right? And so I can do things like chain filters together with, or filter parameters together with ands and ors and nots and equals or greater than or less than or equals and greater than or less than and equal. So I can do all of that stuff. So here's another example of where we can do neat things with NMCap. So in this example, I'm going to start the capture at 3:17 p.m. on September 10th. And this is an old example, obviously. All DNS frames that contain a queue record question that have my computer will be saved in a capture file. I'm going to call it dns.cap. The size of the capture file will not exceed 6 megs. And if the user presses X at any time, it'll stop the capture. Otherwise, we'll stop in 10 minutes. And so the command line string is nmcap / network asterisk. So all NICs start when, and then I can specify a time and a date, and then capture, and then contains dns.queuerecord.question name, and then my computer, whatever string you want. And then stick that in a file called dns.cap, which has a maximum size of 6 megs, or stop when, time after 10 minutes, or terminate when I press the X key, key press X. So there's a lot of flexibility here. You can start at specific times. You can specify the length of time. You can stop when after a specific period of time. I can also stop when after a specific date or time, right? Or I can terminate when a specific key press occurs. So in this case, I'm going to do nm / network asterisk, so all NICs, start when, time after 10 seconds, or that might be 10 minutes. I didn't specify it in the example, and I should have. / capture IPv4.destination address equals 192.168.0.1. So capture anything that has a destination address of my default gateway, and then stick that in a file called ip.cap. Stop when, time after 10 minutes, or terminate after I press the C key. And I changed the key in this example just to show you that you can define any key you want. In this case, I'm going to capture on all NICs. I'm going to start when I see a frame that has a tcp.flags.syn equals true. So start when I see a SYN request and an IPv4 address of 192.168.0.1. So think about what I'm doing here. I'm starting the network trace, and I'm saying, look for a packet that contains a SYN request to or from this IP address. And then once I see that, start capturing, right? Put that in a file called t.cap, which has a maximum size of 8 megs, and then stop when I see a frame that has tcp.flags.fin equals true or tcp.flags.reset equals true and IPv4.address 192.168.0.1. So I can literally start and stop based on time, based on time of day, based on day. And I can start or stop based on contents of a specific packet, right? So really neat and really flexible. NMCap is pretty neat. So I've already done some traffic analysis here, just a little bit. The trick to capturing and analyzing network traffic is understanding what's important and what's not. You should know what you want to capture, the endpoints that are involved, and the protocols that they use to transact. And that's all true. Hang on just a second. Common issues I see, asymmetric routing. I don't know if you guys have run into any asymmetric routing issues where we send traffic out one firewall and the response to that traffic attempts to come in via another firewall. That's never going to work, right? I send a SYN request out firewall A, it's waiting for an ACK-SYN. If that ACK-SYN comes in through a different firewall, that firewall is going to drop the ACK-SYN because it has no associated SYN request. So I see asymmetric routing quite frequently. Client-side issues. I see failures when we're talking to proxy sometimes. If a client's incorrectly configured, maybe has the wrong PAC file, or if there's a transparent proxy, but the proxy isn't configured to pass traffic to a specific endpoint, I'll see that. Client sends traffic to endpoint instead of proxy, firewall drops traffic, meaning that we try to bypass the proxy and the firewall says, oh, you didn't go through the proxy, here's a ACK reset for you. And so we see issues like that all the time. SSL and TLS. Most customers by now have TLS 1.0 and 1.1 disabled. But if you're using .NET Framework actually by default does not adhere to the system defaults for SSL and TLS. So I see this quite a bit. I've got TLS 1.0 and 1.1 disabled, but in my network trace, I still see TLS 1.0 or 1.1. And usually it's because .NET Framework apps are running on the box. And there are two registry keys that you can set that will force .NET Framework to adhere to system level TLS defaults. Those are the registry keys: HKey local machine software, WoW 6432 node, Microsoft, .NET Framework, and then the version of .NET Framework. And you have to do this for every single .NET Framework version. And then system default TLS versions, DWORD, turn it on with a 1, and then SCH use strong crypto DWORD and turn that on with a 1. And we'll now go out and use whatever the system TLS defaults are. Filters that I use all the time in every trace that I look at. I always look for TCP retransmits and TCP dupacks. And I do that so that I can gauge network health. If I'm seeing a bunch of retransmits to a specific endpoint or a bunch of TCP dupacks, those two things can tell me different things. And I'll go over that in just a second. TCP SYN retransmit, I'll always filter for that, especially if somebody's saying, hey, I can't connect. Okay, well, were we able to establish a TCP session? And if I see a bunch of TCP SYN retransmits, I know that we weren't, right? If I see a SYN request and an ACK reset, I know that something actively denied that TCP session. And those are really the only two TCP level scenarios that can prevent us from connecting. I'll send a SYN request and I either won't hear anything and then I'll send a TCP SYN retransmit, or I'll send a SYN request and I'll get an ACK reset, which means that the endpoint didn't have anything listening on the port that I'm trying to connect to, or there's a firewall in between me and the endpoint that's not passively dropping packets and it's actively refusing TCP sessions. And so those are the scenarios I look for when somebody says that they can't connect. Now, it's entirely possible that they can connect from a TCP standpoint, but can't connect from an application standpoint, right? And there are things that can happen on the wire that we can look for. Were we able to negotiate TLS? If we were able to negotiate TLS, did we issue a client hello and did we get a server hello back? If we got a server hello back, do we like the certificate that the server returned? And then the next thing that I'll look for is encrypted alerts. Did we get any encrypted alerts? Because it's possible that I got a certificate back and then the certificate I got back has something in it that I don't like. So I'm gonna refuse the session based on the certificate. And so there are some things that I have here that I want to show you that help figure that stuff out. So I'm going to stop the slideshow. Any questions about any of the stuff that I just went through? And I have to be careful because I'll go over. Any questions?
No, you're doing amazing. Yeah, this is definitely just soaking it all in.
Okay. And luckily it's being recorded, right? So you can hold me to it. Okay. So let's talk about the last thing that I just talked about first, which is encrypted alerts. And I have an encrypted alerts list. And we talked about earlier on some things that Wireshark does better than Netmon. Wireshark actually parses encrypted alerts better than we do. But I'm going to show you how to parse an encrypted alert anyway. These are the possible returned encrypted alerts values. The first encrypted alert that you'll see normally is a close notify. And a close notify is completely normal, right? That means, hey, I'm done talking. I'm going to close the TLS session. And so we'll call an encrypted alert in a lot of cases, and we'll populate that with a close notify, which means, hey, we're done. We're going to tear down the TLS session. Usually you'll see that after an ACK-fin. So one of the endpoints sends an ACK-fin. We respond with an encrypted alert with a close notify, and all is well. And then we'll send an ACK-fin and the TCP session will be done. But if I send a client hello, I get back a server hello, and then you see an encrypted alert that's 2 bytes, that's usually fatal. And that's one of these other issues: unexpected message, bad record MAC, decryption failed, record overflow. Normally the ones that I see commonly are handshake failure because we didn't like something in the handshake, right? No certificate reserved, bad certificate, unsupported certificate, certificate revoked, certificate expired, certificate unknown. It's pretty funny. I'll get customers that have been working on issues for months, and I'll look at a network trace and I'll say, oh, you got a bad cert. What do you mean? Yeah, you got a bad cert. Look, certificate revoked or certificate expired or certificate unknown, right? Or unknown CA. That's another one that's pretty popular. Access denied. That's another great one. So if you understand how encrypted alerts work, you can decode a lot of TLS session failures. And so I use this to do that quite a bit. Now, like I said, Wireshark does that pretty much automatically. There are some that Wireshark doesn't always parse, but for the most part, Wireshark's very accurate in parsing these. Network Monitor does not parse these by default, so you have to actually go look at the encrypted alerts. And some people don't like doing that. I kind of think it's fun, but I'm weird. So let's go new capture. And we'll do start. And I'm just going to pull down, I've got a filter already that I'll share with you guys that I use for encrypted alerts. And it is right here. And I'll make that bigger. That's the filter that I'm going to apply. And let me make this area bigger for you. And I'll explain the headers that I like in just a second. These columns are the columns that I really like. Okay, so we're capturing. I'm going to apply the filter. Let's see if we get any encrypted alerts. Let me fire up a web browser. I got to find the web browser. It's actually behind the camera. Hang on. Okay, there's the MSN page. Let's go to some web pages that I usually visit. Reverb. Let's go to Facebook. Let's go to Amazon. Oh, look at that. There's a new Lord of the Rings movie. Got to see that.
That's the series.
Oh, is it a series?
Yeah, they're coming out with a new series.
Ah,
They have to keep up with the Dragon, whatever series.
oh yeah,
from
the
HBO Max. Yeah.
what is that? Man, I used to watch that too.
House
Yeah,
of
the
the
Game
Dragon.
of Thrones. Yeah,
Game of
like a
Thrones.
spinoff. Yeah. Yeah.
That
should be enough. Okay, and there we go. So we got a ton of encrypted alerts. All right, so if I'm going to reapply that filter real quick. Here they come. And they all meet a color rule that I have defined. Okay, so I'm going to show you the trick that I use. So this is a typical encrypted alert. And if you look at the length, it's 26 bytes. It's 001A, right? So 1A in hex is 26 in decimal. So, and 03, by the way, 0303 is TLS 1.2. If I change this, and I can edit this, if I edit this, if I make it 0302, that's TLS 1.1. 0301 is TLS 1.0. But 1A is 26. So this is 26 bytes in the encrypted alert payload. So I automatically know that this is not an error message. But first byte is 00, right? So if we come up here, nothing specified for 0. Okay. Next byte is 00, which is a close notify. So if it's 26 bytes, it's almost always a close notify. In fact, it always is a close notify. But if I come up here and I'm just gonna, I've stopped this capture. Let me save this file, save as, and we'll save this as encrypted dash alerts. And let me just stick it on my desktop. So here's a little known fun fact about Netmon. We used to allow you to edit packets and retransmit them. Somebody figured out that might be a little bit of a security issue. So in Netmon 3.x, we pulled the ability to do that. But you can still edit packets. You just can't retransmit them. Okay.
So Lex, that feature is still in the old version of Netmon?
If you can find it.
We'll find it.
There are a lot of tools, though, out there that'll allow you to do that. All right, so I'm going to take this packet and I'm going to create an encrypted alert that matters, just so that you can see what they look like. All right, so there's our 001A right there. So I am going to delete everything in this up to that point. Oh, I forgot to turn editing on. Okay, now I'm going to delete everything up to 002A or 001A. And I'm going to make it a 02. And then Saeed, what's 40 in hex? Do you know?
At the top of my head, I have no idea.
Okay. Let's figure it out. Hang on. I think it's like, I don't know. I don't know.
I got it. It's
Is it 26?
give me 1 second. 0x to 8.
28. It's 28. I was so
28.
close. I was so close. Okay. So that encrypted alert is now going to be an error. Okay. So first thing, length is 2 bytes. What you want is the value after that 02, right? So this means it's an error, right? Remember our chart. 2 is a fatal error. We know 28 now is 40 because we weren't very discreet. And 40 is handshake failure, right? But if that was certificate revoked, it would be a 44, right? It would be whatever the hex equivalent of 44 is. So 32, right? Certificate expired, 45. Certificate unknown, 46. And so knowing that is actually pretty neat. Now, can I take an ETL file and open it in Wireshark? And the answer is absolutely you can, but you have to convert it. So if I go down here to network class, so I teach a network class all the time. Oops. Yeah, I didn't mean to do that. Hang on. There's my mouse. Okay. So if I go to network class, I've got a little tool here called ETL2PCAP-NG. And so all I have to do, let me go to my temp directory. Yeah, there's PCAP-NG. So let me open a command prompt. Okay. So it's really this simple. There's test cap. All right, so I'm going to go ETL to PCAP-NG. And then I'm just going to call test cap.etl. And I think that's an ETL. If it's not, I'll make it an ETL in a minute. And then we'll go to test cap dot PCAP-NG. I'll just PCAP. What did I do? ETL2. Oh, I'm not in the right directory.
Yeah, you need to be in the right directory.
Yep. Okay, it didn't like that capture file. Is this an ETL? Let me see. Actually, let me just copy an ETL in there. All right, and I'm just going to rename this. Okay, so now up arrow, and we'll call this lext.etl. And since there's already a test cap, -lext. I may have grabbed the one that has no data, but you get the idea. And so that will create a PCAP file. And now all I need to do is double click on that and I can open it in Wireshark. So pretty cool, pretty straightforward. You can capture with PowerShell. You can capture with NetSH, and you can just use ETL to PCAP-NG, which is available on GitHub, to convert those ETL files over to PCAP files if you like using Wireshark. I feel like Jerry Seinfeld, because every time I say if you like using Wireshark, I feel like I need to follow it with not that there's anything wrong with that. But there you have it.
Save as?
Huh?
From Netmon?
Can't hear you.
Can't you do a save as from Netmon?
You can't save Netmon. No, Netmon won't allow you to save as PCAP-NG. So here, so if I do a file save as, I really just have cap.cap. Right. And so the problem with doing that, now you can normally open .cap files in Wireshark, right? The problem is that it's not a standard .cap file. It's an ETL file. So it contains a lot of additional information that Wireshark doesn't know how to deal with right off the bat. And Netmon's the same way. Wireshark now has a new file format, PCAP-NG. It's not really very new, but PCAP-NG contains data that Netmon can't understand by default. Netmon can open PCAPs by default. You've got a regular Wireshark captured PCAP. We can open that.
It's good information. Thank you.
Yeah, absolutely. Okay, so we've got 15 minutes left. And really, we've got as much time as you want left because I'm never going to shut anybody down. Any questions about any of this?
Lex, if you can send me all the material, what I will do, I will have it on a OneDrive, and anyone will email me from the list. I'll share the OneDrive with him. Would that be easier?
Yeah, that's fine. But if anybody has any questions about anything that we've covered, I'm happy to address those or answer any questions you have about anything that we've talked about or any networking questions that you have.
Yeah, thank you.
Let me kill this and go back to Teams.
Will the material include this recording?
That's a good question. Guys, will the material include the recording?
The recording will be on YouTube.
Ah.
Yeah,
really?
And the material will be on OneDrive.
I'm a YouTube star now.
Yes, you are.
I'll admit it, you already were.
Yep.
I have a podcast called Taste of Premiere that's on YouTube.
Yeah, I was going to have to correct you there, Lex. I was like, come on, you've been doing that for a long time. Can you go over real quick too? I was trying to capture, because as you've been talking, I've been trying to share some of the stuff, word for word with links. Show us one more time how you convert the file in Network Monitor to be able to get it into Wireshark. If you could just cover that again.
So you don't do that in Network Monitor, right? You do that.
Right, you do it through command line, right? But
you
what
do it
was
through
the
command line. Yeah.
Yeah,
So
that's what I lost.
That's actually a great question. Hang on just a second. Let me fire up a command prompt again.
Because what was it? ETL to PCAP NG?
Yeah. So I actually
good.
have a utility that's available on GitHub. And hang on, I'm gonna.
Yeah, if you got something GitHub, even better.
So if I open my temp directory here it is actually right here, ETL to PCAP NG. And it's just ETL to PCAP NG space and then source file space destination file. So I feel like I cheated you guys a little bit because it didn't work because we picked a file that had 0 data. We know this one's got data in it. So let's do this, copy. And then paste. And let me clean some of this up.
Lex, can you share your desktop one more time?
Yeah, absolutely. Hang on. You're not missing anything, but
Okay.
I happily will. I'm cleaning things up a little bit because we had a couple of failed attempts here. Hang on. Cancel. Okay. So let me share that. Okay. So there is my desktop, and let me make that larger again.
Not that I want to steal thunder, right? Try to move it into Wireshark, but I know that was a couple questions.
Man, yeah, like I said, I use Wireshark all the time as well. It's Wireshark is great. Okay, so what I'm going to do is rename this file. And the only reason I'm renaming that ETL file is because I want to make the command line pretty easy to understand, right? And so cd/temp, and then because it exists in that directory ETL to PCAP NG space, and then lext .etl space, and then whatever I want to call the destination file. So lext .pcap ng. And if I hit enter here, it's converted the file. Right. So now if I go back to the directory, now I've got lext as a PCAP, and if I double click on that, there you have it. It's open in Wireshark.
Nice. Yeah, thanks, Lex. Yeah, I found the GitHub link and threw it in there too in the link.
Yeah.
In the
Now I can do file save as and save it in some other formats. So really you can like convert stuff from ETL to Wireshark and then go from Wireshark to something else if you want. And I do that a lot as well. Make sense?
Looks perfect.
Yeah. Yeah. Thank you.
Okay. Any other questions, folks? And I don't actually have tattoos. That's a shirt, just so you know. Any questions, anybody? Okay. Well, thank you all.
Thank you, Lex.
Fantastic. Thanks, Lex. Thanks for your time, and thanks everybody for joining. Really
Yes.
appreciate it.